Now, the purpose of this video is to teach you how to use the vernier caliper. We will start by learning how to note the reading from a pair of vernier calipers. This needs to be done step by step. Our first step is to find out the zero error. What? What is that, you asked? Well, when you close the jaws of a vernier caliper, sometimes what happens is that the zero of the main scale and the zero line of vernier scale coincide. They should coincide, as you can see in the figure here. If we keep looking at this figure, you'd realize that it explains that the zero error can be either positive or negative. If the main scale and the vernier scale don't coincide, it means that there is an error. This error is positive if the zero line of the vernier scale is on the right side of the zero on the main scale, and it's negative if the zero line of vernier scale is on the left side of the zero on the main scale. Come, let's look at an example. The question states that we have to find the diameter of a solid cylinder placed in the outer jaws of the vernier caliper as shown in this figure on the screen. Now, what should be our first step? Well, the first step is to find out the zero correction. Now, what is this new fancy term? Oh, don't let it scare you. It's very simple. On closing the jaws of the vernier caliper, the vernier divisions coincide with the main scale 7th division. So this 7 is multiplied by 0.01 and the least count becomes 0.07 centimeters. The main scale reading here is 0.0 centimeters. So the zero error is positive 0.07 centimeters. Now open the jaws wide enough to hold the solid cylinder to be measured. Close the jaws gently until they touch the cylinder. Note the value of the marking on the main scale just before or touching the zero mark. As you can see in this image, the main scale reading comes out to be 2.2 centimeters. Now look for the marking on the vernier scale, which coincides with any division on the main scale to form a straight line. Upon looking at the figure, you'd notice that it is the 6th division. Now multiply this 6 with the least count, which is 0.01 centimeter. There you go. The vernier scale reading is 0.06 centimeter. So the observed diameter of the cylinder is 2.2 centimeters plus 0.06 centimeters, which is equal to 2.26 centimeters. We're not done yet. Now you have to subtract the zero error, which is 0.07 centimeters. Therefore, the correct diameter is 2.19 centimeters.